while I love the language, simplicity, it's great. I love the language, but my favorite feature is the tool chain. The Go tool chain, just that Go command. It's great. We can do all kinds of things. So we can build, we can test, we can format our source code, we can get dependencies, we can do code coverage, we can do performance profiling, we can do race detection, like all those things. It's crazy. But as we start to get into it, we spend 99% of our time inside that tool, but there's that 1%, what's that next step? So, as developers, we want to kind of build our own tools. So we start to do that, and we start simple. Maybe we start with code generation. So we have simple print statements, put out some code, and we, generate some boilerplate, which is only so useful. Next, we might go to, the Go sub packages. So we have Go AST, we can parse, we can scan, tokenize, we can get this abstract syntax tree. We can do a lot of stuff with that. So I wrote a tool called MegaJSON a while back, and it's great. We can parse out a Go program, get the structs for it, generate JSON decoders, encoders, and it's a great use case for that kind of thing. So this is actually, it's a popular approach. If you go on godoc.org, you can see that over 1,000 packages import Go AST. But the AST is limiting, so it only shows the structure of your code, kind of the layout of it, but not how your data flows through. So we want to move on to something bigger and more advanced. So we can use static single assignment intermediate representation, which is quite a mouthful, and there's a much simpler way to say it. SSA IR. That's what we're going to talk about today. And why does it matter, and why is it useful? So SSA IR, it shows how your code flows, how your data flows, from different variables to different functions, different blocks and sections of your code, and how those values flow through. And the best part about SSA is there's a package for it. Written by Alan Donovan, who's here. I actually met him the first time at the kickoff party. And if you're around, raise your hand. Yeah, right there. He'll answer all your questions later. He's also very well dressed. He always dresses up nice. Best dressed person in the Go community. So yeah, he's a primary author. Really smart guy. I've read through his code. Uses a bunch. It's a great package. He's also written this book here coming out. And I gave him a hard time for this, but he wrote it with Brian Kernighan and somehow got his name first. I don't know how that works out. Turns out they did it alphabetically. Go AST is really popular. You go on godoc.org, and only 5 projects import this package. It's very powerful, but I feel like it's the most underappreciated package in the Go community. And how few is 5 packages for projects? You can fit them all on one slide, and this is everyone out there that actually imports it. So let's break down SSA IR. So intermediate representation, let's start with the IR part. So all that means is that we have a layer in our code, our representation, that sits in between our Go code and our machine code. So our Go code is where the AST lives. It's kind of the structure of our code. And it shows the layout, but it doesn't show kind of that flow of data. Whereas the machine code, it'll actually kind of show the flow between jumps and registers, but it's all machine specific. So we need something right in between. And IR is high level, so you still have these Go concepts like Go routines, and you have functions and types, but it's also, it's portable. So we can actually run it on AMD64, we can run it on an ARM processor. It's all the same code that we analyze. Okay, so that's the IR part. Let's talk about SSA. It stands for Static Single Assignment. I actually spent time practicing saying static single assignment intermediate representation because it's that hard. So this is normal Go code, which you normally see. You set x to 1, y to 2, and now we set x to x plus y. But this isn't allowed in SSA. So the problem is that we can't overwrite our variables. We can only set them once. That's the single assignment part of it. So what we do is we version the variables. So we have an x1 now, that's 1. We have a y1, that's 2. And then now we can see x2 comes from these 2 other variables, these versions of the variable. Now you see this a lot in functional languages, but when you take your Go code, you can bring it down to this SSA form. You get a lot of that benefit of single sign-up.